Hello, everyone. My name is Jason Adrian, and I'm a storage hardware architect with Microsoft Azure. And today I want to talk about the future of hard drive interfaces. In 2025, how do we want to connect hard drives into our storage systems? Do you want to use the existing infrastructure we have today, or are there things that might actually be better for us? So, do we even need a new interface? I mean, we've had SAS and SATA for a long time, and they've served us well. Should they continue in perpetuity? Or do we look at the SSD market and how other non-volatile media has moved over to PCI-connected NVMe devices? For hard drives, it's easy to see where we've been, but we can still shape where we're going if we're looking ahead. So this is a potential. We could unify the interfaces of hard drives and solid-state devices. And here's where we believe that NVMe hard drives are the next logical step. Why do we think this? So it eliminates protocol translation. The PCI Express bus is a native interface to the CPU, and we have PCI switches with very high lane counts. These are already used in other devices that we ship today, so it's a very logical conclusion that we can use those for hard drives in a similar manner. So while the industry might not see the immediate need now, we're talking about a very long journey. The planning that we do today affects the hard drives and systems in 2025 and beyond. So what does that look like when you start talking about these new system designs with a hard drive that's connected on the PCI Express bus? So what can we do? You can eliminate the SAS controllers, for one thing, which is interesting, and we can connect directly to the host CPU for low to moderate hard drive counts. And that's with today's technology. In the future, we might be able to get that higher. And the other things that we can think about, the PCI Express switches already have that high lane count. Just put them in there. So you can trade out a SAS controller and a SAS expander for a single PCI Express switch. Now, there may be pros and cons of placement and layout in a system, but it is something worth thinking about. And we also have the ability to do multiple PCI Express switches like we do with SAS expanders. And as we start thinking about new protocols and new technologies, what's coming down the pipe? We have multi-actuator hard drives out there in existence today. And we found that SAS made a lot of sense for those because it had the concept of multiple LUNs. Now, as we start talking about 2 and 4 actuators on a device, we can look at NVMe and namespaces, and that might be a nice conducive way to enable multi-actuator technology. I think the key important takeaway here is we need to keep it simple. Obviously, an NVMe attached hard drive has a lot of challenges. However, there are a couple things we can do to keep it simple. So we only need a single PCI Express lane. We don't need multipathing for most solutions. But if some of the OEMs out there need dual porting, we can certainly do that with 2x1 lanes. And for the current drive generation, a single PCI Express JN380 lane has enough bandwidth. In the future, if we're starting to talk about a 4-actuator device, maybe in a 2025 timeframe, then we might actually need to consider PCI Express Gen 4. The trade-offs obviously are going to be signal integrity and how far you can run these traces. So in the beginning, we might want to keep it simple, but over time, we likely will need to speed that up. However, we don't need to make it the same speed as a cutting-edge PCI Express lane because hard drives simply can't saturate it. And one big request we have here to all the vendors looking at building new silicon, if the host CPU root complex can support x1 PCI Express bifurcation, we can actually put a lot of drives directly onto the host ASIC. We won't need to use PCI Express switches downstream. And there are other opportunities here, and you've seen this in the industry already. You can put hard drives behind a smart NIC and allow the NIC to do some lightweight processing. You can do computational storage, whether you have an ASIC or an FPGA, you can actually go across multiple hard drives without going to the host OS. And obviously, as we talked about in the beginning, having a mix of hard drives and solid-state devices in the same driver stacks with the same offloads and the same interfaces has a lot of benefit. The key here is we need to plan for success. This isn't going to happen alone. This requires the industry to move together. We must continue to look forward and define the future, not necessarily be complacent with the solutions we have today. If I had been giving this talk in 2004, we would have been talking about fiber channel attached hard drives and the concept of SAS and SATA taking over the industry. And they did. we ended up having SAS and SATA completely take over the drive market, and we haven't had a fiber channel drive probably in close to a decade now. But where will this road take us? We won't know unless we explore this option. However, what I do know is that we need to do this together. So please join us in looking at the NVMe attached hard drives and the opportunities that it entails. And in addition to joining us, you can join us on the mailing list. You can look into the NVMe subgroup that we're looking to form. Within SNIA, there's investigations on the NVMe attached devices to see what pros and cons there may be and how we get there. Because the NVMe specification really was meant for solid state devices. It didn't have the concept of slower, longer latency hard drives. But now's the opportunity to explore that and look into that. So please join us, and we look forward to seeing you there. Thank you.
All right, thanks everyone for joining us this morning. Hopefully this was interesting, but what we really want to talk about is how do we move forward? Ideas are great, but it only starts moving forward if we work on this together. And I think the key takeaway that I'd like people to think about with this presentation is we have interfaces today, but we're talking about drives in 2024 and 2025. Now is our opportunity to work together to influence what those drives look like. So if you have questions, continue to send them in the chat, and I'll try to answer them as we go. Looks like we have a couple questions. All right, so the first question is, would you envision enclosures that could accommodate either an SSD or hard drive NVMe device, or would you expect PCI by 1 bays and by 4? I think this is a challenge. In the past, we might have had a common enclosure, but I think at this point, I don't think a common enclosure makes sense. I think we've seen the form factor split. So we have a U.2, which is similar to a 2.5-inch hard drive. The 2.5 hard drive market is dead. All the hard drives from now on are going to be 3.5 or other form factors like that, and we're seeing flash move into specialized form factors, as we'll talk about in the next couple sessions actually, with things like E1.L, E1.S. So I don't expect common enclosures, but I do expect common management paths to the devices, and I expect a lot more commonality in our management stack. So as we hear about things like computational storage, that's where you might want to deploy some technology against a hard drive in some applications and against an SSD in another. And depending on how you build, whether it's an ASIC or a software stack, you can't really do that as easily today. You have to have some layers in between. So if you have a SAS drive and you have a PCI Express attached SSD, well, on one you're going through the NVMe protocol, and the other you're going through a SCSI protocol. So I think these are some challenges. I think this is where we can find some of the unity. The next question is the SNIA and the OCP efforts to be two distinct efforts. I see this in two different ways. What I'd like to see us do in the OCP community is really talk about the use cases and high-level product definition. OCP, we don't want to be a standards body. We don't want to go defining this is what a bit means, this is what a register means. We want to talk about the high level. So we can all unify and say, look, we think there's value in an NVMe hard drive. These are the characteristics and features we'd like to see. That's what I think we'd like to have coming out of the OCP community. And we can take that to SNIA or other standards bodies to actually drive the true definition. And the next question is, yes, we do want to start an NVMe hard drive subgroup. And that subgroup, it's similar to a mailing list, but it's really for us to get together and talk about the pros and cons of should we do this. And if the answer is no, that the value proposition just isn't there, great. We can stick with SAS and SATA. But if we get together and we start deciding that there is enough value to look at this further, we should absolutely do that. The next question is, yes, so this was a short talk intentionally. The way this presentation was meant to begin, and you'll see the next couple, this was meant to be a primer with a lively panel discussion. Obviously moving this to the online virtual forum, and we decided to cancel the panels, made this a very high-level talk. So we can certainly provide a lot more insights and details, but we're hoping to make this a collaborative discussion and debate. I mean, I certainly expect people to say, this is crazy. And you should. I mean, a new technology, a lot of people think is crazy to begin with. I think as time sets in and we start looking at the pros and cons, we can determine if a technology and a path forward makes sense, or if it's something that we better just leave it be and deal with our current technologies. Let's see. So next question's what would the intersect probably between SNIA and OCP be doing together? So I don't want to call out SNIA specifically. I know we've kicked off some work groups there. There may be other standards bodies where we need to define this as well. So I think we should continue to have that discussion of where should we do this definition. Another question of TCO benefits, moving the NVMe hard drives. I think different use cases will show different types of benefits. In the Microsoft use case, I believe we have some ability in future designs to have an actual benefit, yes. Pulling out SAS control and a SAS expander and being able to replace that with PCI Express switches or directly connecting to a host CPU certainly opens up new design options. And I think we'll start seeing different enclosure designs, different system designs that can make use of that. But I think even more interesting will be use cases where people are trying to do a computational storage-like offload device, whether that's an ASIC or an FPGA that may need to access host memory, an SSD, and some hard drives. I think this would certainly benefit opportunities like that. And whether we adopt it and others in the industry adopt it, I think there will be a lot of value. So I'd encourage people in the computational storage space to think about that. Obviously, more of the value currently is in SSDs, but I believe there's some for the hard drive as well. The next question is there any known development work with a bridge to do SAS or SATA to an NVMe? We could certainly do a bridge, but I think you start to lose the value proposition. The goal here is to make it simple and reduce the amount of hardware in between. So a bridge would certainly make it better from a software perspective, where we could have a common set of drivers and interfaces, but I think doing a bridge simply wouldn't make financial sense. I think it's a great way to kick things off, get the development going, but I don't see that being a viable long-term solution. I think if drives go the NVMe route, it needs to be a native direct attach to the drive itself. And I think that will start simplifying things. If you look at what's inside of a hard drive and what's required for the SAS controls, especially today with a dual-ported SAS controller, that's a lot of ASIC space and a lot of development work. And I believe the NVMe interface would be a substantially lighter lift in the physical design aspects. Obviously, driver stack and the ecosystem has a lot of work to do. Next question. Given each hard drive lane PCI will lead to low utilization of all that PCI Express silicon and die area. That's certainly a valid question. However, if you think about designs, let's pretend we get the CPU vendors to bifurcate down to a by one. That's kind of one of the main asks that we've had in some of our face-to-face groups. So today's Intel and AMD CPUs have 40 to 64 plus lanes of PCI Express or more. And you can imagine that a device where you're putting, let's say, a by 8 or a by 16 to your Ethernet interface, and maybe you have another controller or two in the system, but you might have many, many extra lanes. That would be useful. Now, the trade-off is that you actually are adding a little bit of cost to have the root complex bifurcate down to by ones. So maybe that's a good use, maybe that's not. One could argue that in a PCI Express switch, if you substitute that instead of a SAS expander, there should be similar costs, and those can bifurcate down to by ones. And we can influence those roadmaps as well. And that lets you, if you need to fan out to many devices and many drives, like you might in a SAS-style architecture, you still have that ability. So I think from a TCO perspective, that's going to be probably a wash if you end up putting a bunch of PCI Express switches instead of SAS expanders. See, the next question. Is there any known development? We've certainly been talking to the device manufacturers about the interest here. So this is not something new to the ecosystem, and we're probably not the first to propose this as well. But I think the key is we don't want to go this alone. Going things alone awfully is problematic and it's expensive. That's why we'd like to get the community to think about the value proposition and work together on making progress here. Working on NVMe hard drive enclosure management specs. So that's actually an interesting question. I have not thought about that particular aspect. In my view, the interest in an NVMe hard drive is to connect it to a local complex and have that complex be a storage node. And most of us in the hyperscale world, we are Ethernet connected into our systems. So I don't know if we want to expose something like a SAS JBOD where you would need an enclosure management scheme to something external. I would liken this to something where it's a single enclosure that has your storage subsystem behind either a processor or a SmartNIC or something that's doing the actual translation for you. Let me see. More questions about the IP blocks. Yes, we certainly have to look more about this. But I think if you look at a SAS expander and you look at a PCI Express switch, so pick a lane count, and I think you'll find them to be fairly close today. And I think economies of scale, you should be able to get them very similar. The one benefit that's a little easier to justify is you can get rid of a SAS controller. So today, if you want to go down the SAS path, you are buying a SAS controller and you are buying a SAS expander if you can't connect all your devices directly to that. Let's see, given the proposed timing for a solution, do you see this as a limit to multi-actuator hard drives? I think there's a lot of benefit to multi-actuator. I think so. SAS and NVMe give it a really good interface opportunity compared to SATA, but I don't think we should limit that to multi-actuator. Maybe if those are carrying a cost premium due to the extra actuator or multiple actuators, it may be easier to justify, but I think the goal here is that if we think this makes sense for the industry moving forward, and I certainly do, we want to make sure it's across all drives. We can't have certain devices having NVMe and certain not having that, because when we design an enclosure, we really want to be able to take any device we see fit. So whether that is a low capacity single actuator, or a high capacity single actuator, or some of these multi-actuator devices, we want to be able to switch. I mean, our businesses will define when we need certain technologies, and we don't want to limit ourselves to one enclosure for one, a different enclosure for another, if we can help that. Next question. PCI controllers are much larger than SAS controllers. They certainly have more functionality, but I think the PCI controller itself, I think you're looking at the host complex. And yeah, that is complicated, it has multiple links. But I think if you look on the device side of SAS versus PCIe, I think you'll find from a PHY level they're very similar, but from a functionality level, SAS provides a lot of mechanisms that really aren't present in PCI Express. It was meant for devices that can, be hot added, hot removed, and a lot of link retries, whereas PCI Express has always been meant to be in a box, and it's only in the last couple of years that we've had some of these surprise removal and surprise insertion capabilities. So I think we'll have to work on what the differences are. Let's see. Next question. A PCI switch may be cheaper than a SAS HBI and expander to fan out to SAS and SATA hard drives, but going to NVMe and enabling more by one ports on a CPU, could wash out benefits, yeah. If we're looking solely at hardware cost, I don't expect that this is going to be a big win. The path here is not to save money on the bill of materials. Building hardware is one thing. Getting something into production and managing a fleet of tens of thousands or hundreds of thousands of devices is challenging. The key takeaway here is the closer and the more similar we make our hard drive and our SSD interfaces and our management schemes, it allows us to deploy and manage our fleets a lot better. I think that's the main takeaway. Next question. Do we care about U.2 and U.3? From a hard drive perspective, no. From a flash device perspective, I think U.2 certainly has a good place today, but from the Microsoft perspective, we believe that the EDSF form factors make more sense for us, and I'll actually be covering that in a few hours this afternoon, talking about E1S and E1L, which I think offer quite a bit more value to us compared to U.2. So certainly bring that up in the follow-up questions later on today. Next question. The signal integrity of PCI Express has been worse than that of SAS. And yes, absolutely. So the PCI Express is nowhere near as durable of a PHY as SAS would be. I would liken it more to a SATA interface. But I think in the hyperscale area, at least speaking from our perspective, we don't want to fan these things out to gigantic systems and do multiple enclosures. What you'll see if you look at some of the enclosures on the market, you may see tens of drives connected to a single device. And in that case, if it's the CPU, that may make it more difficult. But if you're putting, let's say, 30 to 40 hard drives behind root complex, you're probably going to put a PCI Express switch, somewhere in the center of that to make the signal integrity work. So these are design considerations, and I think they're certainly achievable. Last question I see right now. When do you expect to see this to happen? So this isn't going to happen overnight. I think if the community as a whole sees value in this, and we work with the hard drive vendors to make this happen, I think you're looking at a 2024-ish time frame to actually get these devices. And maybe in the meantime, there was a question about bridges. Maybe you put a bridge in front of it, or you have an FPGA program to make a PCI Express to SAS or SATA interface for development. But this is going to take time. But we can't be afraid of investing in time, because hard drives is going to be here to stay. A lot of people will say, oh, what about QLC or 5-level flash? Isn't that going to completely get rid of the hard drive market? No, it's not. We still have quite a bit of ways to go before flash or other non-volatile memory technologies are going to eclipse hard drives. From a capacity standpoint, hard drives have a very healthy future. From an IOPS per terabyte, where some of us are struggling today, that's where a multi-actuator comes in. But I still think we have a minimum of 5 to 10 years of a very solid and viable hard drive market. So spending the time to get the interface that we expect and would like to see in a 2024 timeframe is ideal, and now is the time to start that. And if the answer is we can't converge, or we think that SAS or SATA, even with some of the caveats and challenges we have with them, are good enough, that may make sense. But I think as people start to think about what could you do with an NVMe connected drive, and if you had other devices on the bus that may be able to talk to it or share like an ASIC that goes across them, or an accelerator or an offload, I think that's where people will start to see a lot more value of not having to go through a host CPU, going through a SCSI stack or an ATA stack. So that's what I want people to think about. I think one last question. If the NVMe is introduced as an interface to kill SATA for good, then that is acceptable. Do I see benefits that PCI brings over SAS as an interface? Okay, yeah, so that's actually a really good point. If we look at NVMe attach, or specifically the PCIe attach, I think this is something that would kill off SATA. One of the main reasons we're seeing SATA as one of the highest volumes in hyperscale is it's slightly lower cost on the devices themselves, but it also means you can connect it to a CPU, which people have today. You can actually buy and license SATA blocks if you want to do custom ASICs. So I think there's a lot of value add there. The drawbacks, obviously, was meant to be a point-to-point, just like PCI Express, which is good inside of a box. I think the reason we saw SAS, and it's quite obvious why it came out, when you were thinking of the enterprise storage and you're putting hundreds or thousands of hard drives behind a system, you weren't going to be doing SATA there. SATA multiplexing is just not the ideal. That's where a SCSI and a discoverable and hot pluggable technology made a lot of sense. So what I think is interesting about this NVMe, I think it's a very easy replacement for SATA, and I think honestly even for SAS. I think as we're seeing systems move to more of a scale-out versus a scale-up architecture, having the ability to go over a different type of bus in the front end that's separate from your device interface makes a lot of sense, and I think that makes it an easier sell to move to this in the future. One last question. NVMe might extend the hard drive lifeline. Yeah, I think the computational storage angle is interesting. And it's not just that. It's any sort of offloads or any sort of accelerators that you see. A theme you'll see at OCP, a theme you'll see throughout the industry, is that certain tasks may be very computationally challenging. And if you're using general purpose CPU cores, that takes a lot of power. And when you're paying for power and you're paying for all the space and efficiency, the more efficient you can get, the better. And I think that's where you're going to see this make a lot of sense. And we hear people talking about tiered storage approaches. Well, today we typically don't tier within a single box because we have two different devices, two different types. But when you start talking about NVMe, and you could potentially consider commingled devices within a system, and you may be able to tier a little bit more efficiently. Hopefully that answers all of the questions. I think I got to everything in the chat. But if there are any other questions, if you have ideas, if you want to get involved, please reach out to myself or my co-chair Dave, or pretty much any one of us at OCP or on the mailing list, because this isn't going to make forward progress unless we actually debate this. And I fully expect the debate to find issues and flaws with moving this path, but hopefully people are now starting to see the value proposition that this brings, because the value prop won't be realized for the next couple of years, but now is the time to kick that off. So thank you very much. Please reach out for any questions or if you want to continue the conversation. Thank you.